This is the Audi C7 RS6. It has a 4-litre V8 twin-turbo engine. When looking at the stock intake system, we realised that there was some room for improvement. So today we're going to have a look at the thought process that went through in developing the Eventuri Intake for this car. So we've just dyno tested the RS6. It's made 587.7 horsepower and 600 foot-pound of torque. So Bilal's just now going to talk you through the development of the intake.
So here we have the stock Audi C7 RS6 airbox system. It uses two turbo tubes, but they converge to one opening in the airbox because both turbos feed from the same filter. The airbox has two inlets. First one's here at the front from this duct area, so it draws air from the front bumper. The second one is back here, this opening in the top of the airbox. It's on the cold side of the engine bay, and they've done this because one opening is just not enough. It would have caused a restriction in the system. So we've got two openings and two tubes which converge to one filter. The airbox does a pretty good job in terms of preventing heat soak because, as we'll show you when we remove the airbox, there are multiple sources of heat in this system. The airbox seals against all these sources and keeps the inlet temperatures down as much as possible. So the main contention really are these two tubes which converge to one opening. So under full throttle, you can imagine it's almost as if the turbos are competing against each other when drawing air from the filter. So here's the Audi RS6 engine bay with the airbox removed. We're going to just show you where the main sources of heat are. The first and obvious main heat source is right here, just with the turbos and the exhaust manifold is. There's a lot of heat which comes this way when you're under full acceleration, when you're stationary. A lot of heat soak comes from this area. The second is from the front. So where the radiator is when the fan's on, there's a stream of hot air which literally is pushed into the engine bay from this direction, right down there. And the third, and maybe not as obvious source of heat, is down here. There's a heat exchanger just there, which gets pretty hot during use. And as that heat soaks, hot air rises from this area. So you've got heat coming in this direction from the turbos and exhaust manifold. We've got heat coming in this direction from the radiator and the fan. And the last source is down here from the heat exchanger, which rises up into this engine bay area. Now, the reason we mentioned these heat sources is because our original Eventuri Intake design used two of our filters, housing filters, coming off each turbo, sitting in this area with a heat shield just across here. And it actually lost power because of the multiple sources of heat, which you just cannot shield with a conventional heat shield. We found that our intake temperatures rose further than with the stock airbox system when we used two semi-open cone filters. Having a heat shield across this area and even across the radiator area doesn't prevent the fact that your intake temperatures will rise because of your third heat source, which is this heat exchanger. So in effect, what you're doing is creating a little oven by having a shield across here because your third heat source is filling up that void with hot air. So no matter what you do, anything which has open or semi-open cone filters in this area will get heat soaked very quickly, and your intake temperatures will go higher than the stock airbox. So after losing power from our initial design using two open cone filters and heat shielding, we went back to the drawing board and designed a complete airbox system with individual filters to allow the turbos to run more efficiently. And this is our final design. We've kept the airbox volume as big as possible to give us as much volume internally as possible. We've got two main entries to the airbox. The first one being here, which connects to the duct and draws from the front bumper. The second one is on the rear lid. This opens up to the cold side of the engine, so you prevent any unnecessary pulling in of hot air. And then just generally, it just protects the intake filters from the multiple sources of heat which we illustrated previously. The front of the airbox has this heat shield which has a gold reflective on it. This is to stop the extreme heat soaking into the airbox from the turbos and the manifold, and it does a very good job of doing that. The two tubes you see here go to the turbo inlets. They're actually independent from this airbox, which we'll show you now. Okay, I'll just remove this lid. Now you can see the two filters. The filters themselves are double cone filters. They're urethane construction, so they're very stable in high temperatures. Each tube is again carbon fiber and has a Venturi stack on the back of the tube. I've got one here to show you. So this is one of the tubes we use. As you can see, you've got a nice transition from the diameter of the filter outlet to the diameter of the turbo inlet on this side. This Venturi stack allows the airflow to remain laminar inside this tube as it pulls through the turbo. This reduces the drag on the turbo and allows for better responsiveness. We've got two of these tubes which are independent from the airbox. They slide through the two holes in the airbox and are fixed into place with a rubber edging, which you can see there, and this heat shield which locks the tubes down into position. By keeping the tubes separate from the airbox, installation is much easier because you can manipulate the tubes as you install it. So the last two pieces in the system are the duct and the scoop. The duct feeds the airbox from the front, so this replaces the original duct, skin carbon fiber pre-preg. We try to improve on the design as much as possible by increasing the internal volume of this duct as much as we can, because there's a lot of parts in the way. So it's actually bigger than the stock duct. It connects to the airbox with this rubber edging to seal the join. The last piece is the scoop. This fits just in front of this duct and comes down lower in front of the front grille. So when you're driving, air is literally pushed up the scoop and feeds the duct, which then feeds the airbox. So you've got a better velocity of air rushing through the airbox, even if you're not accelerating. So as long as the vehicle's in motion, we've got good airflow, keeping the intake temperatures down as much as possible. Overall, you've got a good design which helps maintain low intake temperatures, has a smoother airflow to the turbos. You've got two separate filters to the turbos, and so the drag is less, responsiveness is better, and we get more power. Okay, we've installed the full system now. We'll start from the front. So we've got the carbon scoop right there. It feeds in from the front grille. Airflow is pushed up into the front cover, which we haven't installed yet. The airflow goes into the duct here, which then feeds the airbox from this direction. we also have the secondary inlet, which is right there on the cold side of the engine, which feeds the filter without causing any restrictions. And then we have the heat shield at the front, which, as you can see, is in direct line of sight to the turbos and the exhaust manifold. So they do a good job in reflecting that excess radiant heat away from the front of the airbox. You can also see the two independent carbon tubes, which feed to the two independent air filters inside the box. The duct and the airbox, you can see here, is sealed with this rubber edging because there's a lot of heat which comes in from the front radiator. So we've blocked off all the main sources of heat, ensuring that the inlet temperatures stay as low as possible, whilst also freeing up the airflow using two independent filters and two independent tubes.
So we've tested the car stock and it made 587. With the Eventuri Intake it made 606. So it's a gain of around 19 horsepower. It's got good mid-range gains as well, up to around 20 foot-pounds of torque. But obviously, as Bilal explained to you, on the road with the full airflow coming into the car, the V-box improvement on the stock car was 0.4 of a second, 60 to 130, which is quite a significant improvement. Now I would expect those gains to be more when the car is tuned. So as Bilal has explained to you, the process on the development of the intake, the improvements it's made, not only does it work technically, it's also aesthetically very pleasing. It's probably my favorite intake to date. You can order the intake right now from any of our dealers, so have a look on our website, pick your nearest dealer and contact them for a quote and an ETA on delivery.